So I would say I can choose to skip the details of the derivations, but I think it's appropriate for me to do a little bit portion of the details, and then to the moment I can skip, and then you can go back to refer to our textbook. Okay. So now today I'm going to try to find how to express the things in terms of those things. Again, those ones are available in the handouts. So really, in the way you can see more and more information, I couldn't really put everything into cheat sheets. So that means finally we must go to open book and open notes. Okay. So now again, for these sections, our goal is to find the linear, to express the R and V in terms of linear combination of the initial velocity and positions. Okay. And the whole thing was starting from the linear algebra, so that means how can we express alpha and beta per se. So here, let me start from here. I would put into the different steps, and this is different subsections. Okay, this is the first subsections, and that means to show R and V are linear combinations of R0 and V0. So here to show basically in engineering is we're going to find what is appropriate expressions for those coefficients. As long as we can find the expression, then we show people that's it. Okay, so in this way we can try is this say for R0, and we give is in the PQW systems, and we say R0 is say for convenience we say in PQW systems. Okay, so that is let me give any numbers. So x0, y0, and 0. Okay, so that's a PQW. We can ignore this PQW, but here we just really pick up one. Okay, and you know that this one basically the x0 can be referred to is r0 times sine nu, and y0 equal to r0 times cosine nu. We can detail it in this way, but here let me just simply pick up the number. Pick up the symbols for later easy writing. Okay. Okay, the same thing. The V0, and let me define is the V0 and Y X0. What is the symbol there? Okay, so here again, allow me to use dot as a symbol to indicate that is the symbol. Again, here the whole thing is a symbol. The dot has no meaning of time derivative, please. And that is the, again, follow up our textbook notice. Okay? And again, in the similar way, and then you say R equal to X and Y 0, and V equal to X dot, Y dot, and 0. And again, here the dot has no meaning of time derivative. They're just symbols. So let me pick up the whole of the symbols, and we do the calculation to see how can we find the coefficients for the linear combinations. Okay, and the first one to find f, to find the expressions. Of f. And we can try is this, and we simply take the R dot V0, we see what happens. Okay. So on one side, R we simply plug in there, and R have that expressions here I simply plug in. So that is F times R0 and plus G times V0 and dot V0 here. Okay. So from here you can see the V0 cross V0 and that it becomes 0, so only I have F. So that means this one is equal to F times R0. Make this one. Okay, and for this one, you know, this is the, say, if we pick up R0, V0 and say at the pair G. So basically this one is, this quantity is our angular momentums. Again, I pick up this one scenario if our initial condition is at pair G. Then basically this is H, is the angular momentum in K directions. Right? Because the angular momentum is conserved. So basically, doesn't matter initial conditions where that always become this. Good? Okay. So basically here, this is we leave that, we just leave it here. Okay. On the other side, let me pick up this format to on the other side. R cross V, and let me pick up these coordinate systems. For these coordinate systems is PQW, and how about that? Because the K is the out of the plane, out of the orbital plane, and which is aligned to our W, PQW system, perifocal systems. This is our orbit, and we define this is P, and this is Q, and this is our focus. And outer plane is W, and W basically aligned to K. So basically, let me swap to K, W. Okay. So here is P, Q, W, and then here we plug in R equal to X, Y, 0, and V0 equal to X dot Y0 dot 0. We simply implement this one, we see what happens. So this result will give us is this X, Y0 dot minus X0 dot 1. Okay, so here that is in W. So therefore, compared to the two equations, we can find F simply equal to H and XY minus X0, Y. So here we find one expression for F. So that means there exists such a combination coefficient. As far as what is the number of F, and that is not our concern yet. Okay, but here you can see, this in terms of combination that require X, Y, and require this information. We don't know R yet. So here we only show there is a feasible solution, but the solution is not so practical because involve X, Y, that is something we're looking for. We're looking for R and V, but here we have expression in this way. So we need a little bit of work to replace X, Y in terms of the given informations. Okay? But anyhow, here is to show. And so I don't mind, I just show up this one. Okay, so let me continue. So in a similar way, to find an expressions of G, I think the next one is G, yes. So simply here we take the R0 cross R, and that means R0 cross R, and R is R0 plus G V0. Okay. So in this way, the R cross R0 cross itself becomes 0. So basically, that is if G times R 0 cross B 0. Okay. So again, this one we taking the same thing. So that is G times HW. That's the angular momentum for H. Okay. So on the other side, we can implement the same way. So that is P, Q, W, and R0 is, what is R0? X0, Y0, and R, X, Y. Okay? So we compare the whole things, so therefore you can quickly see G will be H, X0, Y, minus X, Y0. So again, we have expression for G. So we can repeat the same process without probably too much difficulty, and we can find another one. So G dot would be equal to H x0 y dot and minus x dot y 0. Okay, and the last one is we have found the F, G, and G dot. So here we found the 3. And what is F dot? And F dot is such that the 4 coefficients, they have one relation. And let me give you one relation. 1 equal to F G dot minus F dot G. So from these relations, we can find the last one, F dot. And how come this relation exists? And let me explain to you here. Let me give you explanations. So R cross V, and this one is give us is our angular momentums vectors, and R cross V we can plug into using the expression here. So R and V, I introduce those one individually. So that is FR0 cross G and cross F dot. Okay, so we do the calculations quickly, and that one basically equal to Fg dot minus F dot G times okay, so this is a scalar multiplied with this. So basically this one, again, this one equal to H. Okay. So with these coefficients and H equal to this one, so therefore this term must be equal to 1. So that means the 4 coefficients, the coefficients using in the linear combination, they are dependent. As long as you find 3, you can always find another one, like this. Okay, so here we have the 4 informations, and let me give a certain, because later maybe I will refer to the equation numbers in my notes. So let me call this is equation 17, and this is equations 19. Oh, sorry, this is equation 20, and I forgot, and I skipped one thing, and F dot basically is this H x dot y0 dot minus x0 dot and that is 18. Okay. Sorry, I skipped this one. I forgot. So basically, you can put this one here. So here is the 4 expressions, and So here we know we can always find appropriate expressions for those coefficients. But somehow those expression is not useful because here if you look at carefully, those coefficients involve the quantities we're looking for. We don't know yet. So the most useful information will be trying to express in terms of those things. So the remaining will be to replace any variable involving the 4 components in the expression. I'm going to express that one in terms of those things. Okay.